We're always hearing about these massive, incredibly complex AI models. But what if a huge leap forward in how AI understands images doesn't come from more complexity, but from a really simple, almost elegant idea?
To really get into this, let's start with a question. What if the way we've been teaching AI to see has a fundamental blind spot, a key piece of the puzzle that's just missing, holding it back from truly getting what it's looking at?
Okay, so this slide gets right to the heart of the problem. You see, the top AI vision systems out there, these vision transformers, they don't look at a picture like you and I do. They take the whole image, slice it up into a bunch of smaller patches, and then, and this is the wild part, they flatten all those pieces into one long single line. It's literally like taking a photograph, cutting it into a grid of tiny squares, and then laying them out end to end.
So what's the consequence of doing that? Well, the AI sees all the individual parts, sure, but it completely loses the map. It has no idea which piece was on top, which was on the bottom, or which two were next to each other. It really struggles to understand those local relationships, and that makes seeing the bigger picture really, really hard. Now, this isn't exactly a new problem. Researchers have known about this for a while, and their solutions up to this point have been, well, kind of brute force. Just crank up the image resolution or just throw way more visual data at the model. And yeah, that helps a bit, but it comes at a massive cost in training time and the sheer power you need to actually run the AI. And that brings us to the core question from the research we're diving into today. Is there a way to give AI that missing spatial awareness without just setting a pile of GPUs on fire? Can we work smarter, not just harder?
The answer is a huge yes. And the solution is so simple, it's beautiful. It all comes down to this number. 6. Just 6 new little pieces of information. So here's the big idea. The researchers behind this new model, LLaVA-SP, came up with something they call visual spatial tokens. Think of it like this. When the AI gets that long, jumbled up line of image pieces, it also gets a tiny little cheat sheet, a map. These 6 special tokens are that map, and they basically restore all that missing context, reminding the AI how all those little squares are supposed to fit together.
But here's where it gets even cooler. They didn't just stop with one solution. They actually developed 2 different versions of this idea, creating 2 distinct flavors of the model, and each one has its own unique way of looking at the world. Let's break down these 2 strategies. On one side, you have LLaVA SP cropping, which I like to call the detective. It's like it pulls out a magnifying glass, focusing on tiny details by working its way from the outside of the image in toward the center. Then you have LLaVA SP pooling, or the artist. This one's different. It steps back to get the whole picture first, kind of like a quick sketch, and then it starts filling in all the specific details. To put it in the paper's own terms, the detective's approach is from central region to global. It starts with the most specific clues right in the middle and then works its way out. This makes it absolutely fantastic for any task where you need to understand the really fine-grained details in one specific part of an image. And the artist's approach? That's from abstract to specific. And this is a lot more like how we humans often see things, right? You get the overall gist of a scene first, and then your eyes start to focus on the individual details. This makes it perfect for getting a general, holistic understanding of a picture. Okay, so the idea is super clever. A simple map, 2 different strategies to use it. But here's the million-dollar question. Does it actually perform any better in the real world? Oh yeah, it works. Big time. This chart tells the whole story. The baseline here is LLaVA 1.5, which was the reigning champ, the state-of-the-art model. And as you can see, both of our new versions, the detective and the artist, consistently score higher. They're just flat out better at understanding what they're looking at. But hang on, here is the real kicker. This part is what's truly amazing. You'd think that getting all this extra performance would mean it has to be slower, right? Wrong. Look at these numbers. The old model handled 576 visual tokens. The new ones? 582. That's just the originals plus our 6 little map tokens. And the speed? It's practically identical. We're talking a massive win in performance for virtually zero cost to efficiency. So the takeaway here is crystal clear. We have a new champion. The LLaVA SP models, powered by just adding 6 simple spatial tokens, managed to outperform the previous best-in-class model on an incredible 10 out of 11 standard benchmarks. That's a rout. So why does this matter to you? Well, first, it's just a fantastic reminder that sometimes in AI, the simplest, most elegant ideas are the most powerful. It proves that a smarter design can be way more effective than just throwing more computing power at a problem. This breakthrough is a step towards AI that understands our visual world more accurately, maybe a little more like we do. And having two flavors, the detective and the artist, means we can start using specialized tools for different jobs, whether it's deep detail work or broad general understanding.
And that leaves us with a pretty fascinating thought. If just 6 tiny tokens, a simple, clever little map, can unlock such a huge improvement in AI vision, it really makes you wonder, what's the next brilliantly simple idea that's just waiting out there to change everything all over again?